2, 1, go. Welcome to another episode of Dr. Jed's Calculus. This section is 7.1, which is integration by parts. Integration by parts, the basic idea here, it's a complicated thing, but it's really not that complicated. The idea is we're going backwards with the product rule. If you remember the product rule, you take two functions, multiply them together. The derivative was the derivative of the one times the other, plus the derivative of the other times the one, right? FG derivative is f prime g plus g prime f. I moved the order there for a reason. Because I want to look at this thing here and just isolate it. That means I bring this over, so I have, actually I'll look at this one, sorry. Fg primes going to equal fg's all derivative minus the f prime g. I'm just basically moving things algebraically. Now the trick here is I'm looking at an integration technique, not a derivative technique. So if I integrate this, I'm the same as if I integrate this and this. Right over here. The integral of fg prime is the integral of the first one, which is fg derivative, minus the integral of f prime g. Now since this is the integral of a derivative, the antiderivative of a derivative is the original. So we get fg. And then this one we'll leave as f prime g. Now, we don't use f's and g's in integration by parts because traditionally we use u's and v's. So rewriting that, where f is our u and g prime now is our dv, we have the integral of u dv equals uv minus integral of, now, v, which is right there, du, which is right there. It may sound confusing, probably does. And if not, that's great. But regardless, it's not as bad as it sounds. It's easier than that. So let's do an example and see what I mean. So here again is the integration by parts technique. Integral of u dv is uv minus the integral of v du. Just remember that, and we'll be great. So our example, we're going to take the integral of x e to the 2x. I've written that, don't look at that yet, because the first thing we want to look at is this is a product. When you see a product of two things that doesn't resolve nicely, well, you might think u substitution, but that doesn't work here because there's nothing to do there. So when you have a real product that you can't do anything else, integration by parts should be an idea. What are we going to do? One of them has to be u, one has to be dv. I'm going to choose u to be x. That's right here. So dv is everything else. Why did I do that? It's a good question, and we will get to it. Let's just say I chose right, and we'll see why later. Because when I take the derivative of this to get du, I get dx. Notice that actually, that makes one of the terms sort of go away. And that's kind of why we're doing it. But don't worry about that. The derivative of this is 1, so dx. The antiderivative of this, well, you integrate it. And I get 1/2 e to the 2x. Now, these are indefinite integrals, so you might be thinking, what about plus c? That's a good question. We'll put a plus c on the end, at the very end, and it works out really nicely. That's all you really need. Why? Because that's the way it works. Don't worry about it right now, it just works. So anyway, here's our du and our v. The integral of u dv is uv minus integral of v du. What are u and v? They're right here, u and v. So I plug them in right here, u, v, minus integral of, what's v? V is this. And what's du? It's dx. I'm just doing that. Then I'm going to rearrange, put the half out here because it looks nicer. Pull the half out here because it's easier to work with because this is an integral we just did. So we know this integral, it's 1/2 e to the 2x. So I just do that, and now I'm putting the plus c. Multiplying it all out, and here you go. There's our integral. That's the integral of x e to the 2x. So how does that work? Well, let's try another example, just slightly more complicated. Get this moved. What do we want to do here? Integral of inverse sine of dx. Now you might be thinking, look, wait, there's only one thing here. But that's not true. There are two things. There's the inverse sine, and there's the dx. There's always the dx, so even if there's only one thing in there, one of them can be dx. Now if there's a dx, that better be our dv. So this is our u. And it's nice because we can take the derivative of this. Well, you should be able to take the derivative of this. This was chapter 3 material. The derivative of inverse sine is 1 over square root of 1 minus x squared dx. It's messy, but that's what it is. The antiderivative of dx, integrate dx. It's like integrating 1. and you get x. So the formula, you're going to get a uv minus integral of v du, u and v, right here, minus integral of v du, right there. Now that's an ugly integral, but this one, we can do a u substitution. Now if you don't like doing a u substitution because we just used u and v, we'll call it a w substitution. W is going to be the stuff inside here with the 1 minus x squared. So dw is going to be minus 2x dx. We've got the x, we need the minus 2. Basically that means we have to put a minus 1/2 in here. So the minus 1/2 comes right here, somewhere, if I can get a pen. There we go. There's the minus 1/2. And we got 1 over the square root of w. Now if I get rid of those minuses, I get a plus. 1/2, 1 over the square root of w actually integrates nicely here to be just the square root of w. So I get the x, inverse sine of x, plus the square root of w plus c. And of course, we don't want to end up with a w, so plug in our 1 minus x squared. And there's our answer. Now I did that really fast. I don't expect you to go quite that fast. But the truth is, it's really, once you get used to it, a very simple technique to use. You just got to remember the formula. Where's the formula again? Oh, right here. And you got to choose what u and v are. Now, I did say there was a question of what u and v are. So the next idea is, what is u, what is v? If you got a choice, which one do you pick? Now the pick is going to be the way that makes it work best. What is that? Well, some things are really hard to antiderive, like inverse sine. We had to do a whole technique there to even do it. So that's not a good choice for dv. On the other hand, some things take longer to break down, like algebra, like x squareds or x's. So they're really good as u's because when you take derivatives, they tend to go away. So the technique to just choose what is u is, the mnemonic I use is liate. Kind of like, I don't know, Italian coffee. Liate. Choose a log if it's in there. If it's not, choose an inverse trig. If there's not, choose algebra as your u. If there's not, choose trig. And last choice, use an exponential. Because they're just so easy to work with. So, our last example here is going to be the integral of x squared cosine of x. So according to this, there's a trig, there's an algebra. This should be our u, right there. There's our dv. Antiderive cosine, and you get sine. Remember, this is tricky. You got to remember which one's which. Antiderive cosine, you get sine. Derive cosine, x squared, you get 2x dx. Plug those in, we're going to get x squared sine x minus the integral of sine x 2x. Now notice, that one still has a product. So we're going to do integration by parts one more time. This is our u, there's our dv, antiderive it. This time, the derivative of 2x is going to be 2 dx. The antiderivative of the sine dx is going to be minus cosine of x. Plug those in. Notice I have parentheses here. Why do I have parentheses? Because all of this is subtractive. If you forget those parentheses, you're going to have a parentheses error, and you're going to have a thing minus when it should be plus or vice versa. Just be careful with that, you'll be great. Here's the original x squared sine x minus, now this is a u dv, so it's going to be uv, the 2x, that's minus cosine x, minus the integral of v du, which is right there. Now that one, pull the minus 2 out, makes it plus 2. The integral of cosine is sine again. And there's our answer. Was it easy? No. But if you do it step by step, it works out really well.